I'm joined by Professor Stuart Sumida, who's worked on films like Kung Fu Panda, Ratatouille, The Lion King. You've worked on some great animations. What exactly is it you do, though, for people who may not have heard of you?
Well, I am by training a scientist. I'm a biologist. I teach and study animal anatomy and movement. And that is something that's, of course, of interest to students who are in medical studies and veterinary studies and things like that. But it is also something that's very important to animators because animation is all about movement. You're acting and you're moving, whether it's a person's face or their body or whatever it happens to be, or a character, could be an animal, or even a creature that's built out of parts that we know from other creatures. You're making things move. And so movement and those kinds of things are key components of my study, but they're also key components of the way we build animation and VFX style films.
And if they were creating a creature from scratch, is it often just taking different bits of existing animals? Like if you were creating a dragon or something, you would look at...
That's right. And it's a great question because what usually happens is that's where students always want to start. They always want to start with a cloven-hooved creature with massive swords and crazy things like that. But in the end, really, all of those creatures, whether they're dragons or centaurs or creatures of your imagination, are usually built out of parts that we already know about. Maybe it's the hoof of a cow, or the body of a lion or a horse, or the wings of a bat. Really, in every case, what we're doing is we're taking apart from something that we can actually study. And so when we create creatures, we're creating them out of, no pun intended, creatures about whom we already know. And if we do that, we then have to select carefully for where we put them together. And that helps drive the decisions we make about the rest of their movement.
So what are some of the common challenges you find for animators when they're animating animal characters?
One of the most important things is getting an animal's movement natural enough so that you sell it as the animal. There's that suspension of disbelief. So the audience is engaged in the story. Yet, you have to have that animal still able to act. Because you need to tell a story with that animal, or that person, or whomever, or that creature. So it has to be something that moves well enough so the audience accepts that it can join the universe of the story, yet has the ability to act, either facially or body language, or in any other case, by its construction as a character.
And something you kept coming back to in your presentation was you are what you eat.
Yes.
How does what animals eat affect their physiology? Why is that relevant?
The abbreviated version of that is that whether animals eat plants or meat has a lot to do then with their body shape. Plant eaters eat plants, and that a lot of plant material is unavailable to you nutritionally. It's all roughage. Whereas meat is easily available to you. So carnivores have relatively slimmer, more flexible bodies. Therefore, they're shaped differently.
And even just their jaws and mouth and something.
That's right. Their jaw positioning is different. Their movements are different. The way they walk and run are different. Well, the way they walk are similar, but the way they run is different. Even the position of their eyeballs is different because they're catching their food as opposed to a plant eater, which is not. And all of those things, which are very predictable, are then useful tools to artists. You can tell them that story once, and that helps them understand a plethora of potential characters.
So that must be great for accurate animal movement, but often in animal movies, the animals are talking, which isn't scientifically accurate, but
sure.
What challenge does that pose then for taking an animal's face and having it move in a way that creates like human noises?
So one of the things what I like to remind my biological colleagues is that we're not making documentaries here, right? We understand that. So the question is, do dogs or mice talk? Of course they don't. They communicate, however. And so the question is, if they did, how could they do it in a way that doesn't feel jarring to the audience? Which means we actually have to study not only human facial expression and the way the human face, mouth, and cheeks and teeth make sound, but we have to then try and translate that to the structures available to us on other animals. And we have to make some creative decisions. Sometimes we have to make some design decisions and so on, but it usually involves studying both a human's way of communicating and the construction of an animal's face, and then making some decisions about how we're going to move lips and cheeks and so on.
So, like, is it about finding, like, a halfway point between the two? Because, like, I mean, in Lion King you have a lion, and I suppose with a mammalian face you can just about make it work, but you also have a bird whose beak is moving like lips. So what kind of decisions do you make?
The farther you get from a human, the more work it becomes. So humans have faces and hands. Well, mammals have faces, and they have digits, though they're sometimes more constrained. The hands of a cat or a dog don't look like ours, but they do have the digits. It's easier to make a monkey or a gorilla act with their hands because they're more similar to ours than, say, a dog or a horse. That being said, the farther you move away from what a mammal is, farther you move away from a human, the more liberty you have to take. So suddenly in a bird, the primary feathers, which are really only used for flying, become a proxy for fingers. Suddenly the beak becomes more flexible than it actually is. And in a very pragmatic way, more of the communication has to be done with other parts of the face. So you can smile with your mouth, but a genuine smile also involves your eyes and the way your eyes look. So if you have an animal that's got a weird-looking mouth, you really have to emphasize, say, the eye component of a smile. And that is something where you're not only studying construction, but literally you have artists looking at psychology and what makes a person respond to a smile.
Does it help for performers like, say, Andy Serkis to go in and do motion capture and spend a long time studying animal movements and stuff? Does that make things easier for the animator, or is that prone to inaccuracy as well?
Okay, you've asked me a really loaded question here, okay? Because the core answer is yes. The more a motion captured actor knows about his or her character, the easier it will be for the animator to do it. Now, that being said, of course, if you're motion capturing something that looks like a human, say the character's an avatar, it's much easier to match those movements.
Yes.
Absolutely. It's going to be a little tougher when you are creating a character like Gollum, which I didn't work on, to be fair, full disclosure. But it's a human-like character, so that's an easier match than something that's not human at all.
Like Smug the Dragon or something.
Right.
Take motion
And so
capture.
there what you're doing is you're using the actor for as much as for inspiration and some of the facial movement as is possible. Now, it does help to understand a bit of the biology. It certainly does. Now, what's the biology of a dragon? We have no idea. So we have to then decide based on the kind of character that the director wants to project on the screen. The other side of that is, for a character like the gorillas in Planet of the Apes or the chimps in Planet of the Apes, we know a lot about the behavior and motion and locomotion of those animals. And with all due respect, almost all of that was wrong in Planet of the Apes. It was... I watched that film with my wife, who is a physical anthropologist, and although the digital effects were massively impressive, the movement was appallingly incorrect. The posture was incorrect, even the hand motion was mostly incorrect. So with all due respect to Mr. Serkis, he was much better in other films.
You heard it here first. Would King Kong be an example? Was that closer to...
King Kong was a fascinating film for a variety of reasons. King Kong, some of the facial animation in King Kong was stunning. It was beautiful acting. It was what animation should do. You looked at the face of that character and you saw the character. You didn't think about someone was captured for this. I was very impressed. The flip side of that is an animal that big could never have done the things he did. So if you want me to believe he lives in my universe, I don't buy it.
So there's a physics component as well, which is so important to animation
so
as well.
If you want me to believe he lives in my universe, then it can't be strictly a monster movie.
Well, I mean, we do have monsters that existed on this planet in a sense, dinosaurs who...
That is correct.
Millions of years ago. You worked on The Good Dinosaur.
I did.
As a professor of biology, you'll have access to lots of wildlife footage and you can study how they move. How do paleontologists piece together how a dinosaur would have moved, and how do you apply that to the Pixar movie Good Dinosaur?
Okay, so what happened... Now, Good Dinosaur, to be fair, is a bit more cartoony than something like King Kong. And I got to tell you, the T-Rex in King Kong looked really good. Couldn't have done what he did. He was much too heavy for that. And none of the dinosaurs in King Kong could have done that. They would have exploded like watermelons. You can't have stampeding sauropods. They can't run. They're like an elephant. An elephant can walk very, very fast, but it can't run.
Right. Okay.
So, in something like Good Dinosaur, you have a double edged situation. It's a bit more stylized and cartoony, so your audience will usually accept when they don't act like a typical animal so much because it looks a bit more cartoony. The flip side of it is you still want the audience to think this is a dinosaur, so you have to give it some of the aspects that a dinosaur would have. So,
well, what do we know about the aspects then?
so for instance, we know that dinosaurs, like the basis for one of the main characters, are a group called sauropods, the one with long necks and long tails. Well, they're very much constrained in the way they could move, very much like a dinosaur, like an elephant. And so that's our closest proxy. We don't know for sure, but we can actually look at their footprints. We find their footprints occasionally, and they're shaped to the same shape of their feet, so we're very confident which prints go with which dinosaurs. And if we see that those match the same style of prints in an elephant, then we know, for instance, that using an elephant as a model for a heavy dinosaur is a good choice. And those are the kinds of things we did. And that's what I got to do when I got to help with that film. We mostly talked about how really big animals walk.
Well, it shows how helpful science can be to the creative industry. How important is that for sort of, I suppose, the scientific world and creative industries to sort of interact, and there's good funding for, I suppose, education, that each is aware of what the other one is doing. So
it is, as you say, an interaction that's very important. You are absolutely correct. But one of the things is that interaction is not yet as appreciated as it should be. One of the things that I like to do is remind people in the animation and visual effects industries just how much science they're actually doing, because sometimes the problems they have to figure out are really quite complicated. They are being given a problem or a question or a hypothesis, and they must sort it out. That's a very scientific approach in some cases. The flip side of it is that scientists have a lot to offer, and it's not always something of which artists take advantage. So I'm keen to facilitate that. But I will tell you that the animation and visual effects industries, I now consider scientific colleagues. They're using very high-tech tools. They're using very sophisticated tools. Anyone who's an animator nowadays is a computer scientist as well. We didn't used to be able to say that. The flip side of it is, for someone like myself, as a biologist, an anatomist, is that art always makes it easier for me to communicate what I do. And imagery is one of the most fundamental and most powerful tools in medicine. Bioimaging is one of the most important diagnostic tools we have. So biological imagery and modeling is going to be the way we communicate this to our patients. So I foresee a much greater overlap between our industries as time goes on.
So it's like a good positive feedback loop. Like if the arts become more scientifically literate, they produce work that increases scientific literacy, and it just kind of...
That's exactly correct. And one of the things that it also does is it helps us convince the youth of today that art can be scientifically exciting, and it lets us convince the scientists of today that science can be artistically beautiful, and it gives a greater appreciation for both. And when that appreciation exists, then the collaboration begins. And we're always better when we collaborate than when we stay apart. Always.
On that note, I wanted to bring up a story you were telling about an animator on Pocahontas was using you as the basis for her. I was like, do animators often play jokes on each other like that, where they'll take a real person they know as a basis for what they're drawing?
Okay, there is a grand tradition of caricatures of artists being slipped into films all the time. One of my favorites is that if you watch the film Aladdin, there is a scene where Aladdin is running from the guards and he falls into a pile of dung. And the person who is shoveling the dung is a caricature of a crazy, funny, and well-known animator named Tom Cito. And Tom was very proud to be the person caricatured in that. In the same film, in the crowd scene during the parade, many of the people you see in the crowd are caricatures of animators. My very good friend Charles Solomon was caricatured in one of the scenes in Fantasia 2000. This happens all the time. Now, tiny moment in that world is not so much a caricature, but you can't see me on this podcast, but I can tell you I have a very angular jaw because I grind my teeth at night, and my jaw is overdeveloped for the size of my teeth. And when Glenn Keane, who had just come off of Little Mermaid, had to create a female character that looked utterly different from the Little Mermaid, and the Little Mermaid looks very much like his wife Linda, by the way.
Oh, okay.
Pocahontas could not look at all like the Little Mermaid. So he gave her an extremely angular jaw. And it was noticed that my very angular jaw was quite like hers. And so at the end of one of the presentations I did at the Disney Studios, Glenn presented me with a drawing that said, "Dear Stuart, thank you for the wonderful lecture and the inspiring jawline." So, in fact, it has been suggested that my jawline has something to do with Pocahontas' jawline.
Along with your complexion and your long, jet black ponytail.
Well, okay, perhaps, but at the time I had shorter hair. Now,
okay.
my response to Glenn was, "Really, Glenn? It couldn't have been someone as macho as Tarzan?" And he just laughed. He just laughed.
Oh, thank you very much for joining us on Film Ireland.
My pleasure. Thanks for having me.
Do come back.
Will do.